Okay, I'm back. Since we have whole number ratios here, we can make this now into our empirical formula. So we have 1 mole of carbon, so we've got carbon, and we could put a 1 down there, but we won't since it's a chemical formula. Then we have H, and we have 2 H's, and we have 1 oxygen. So for this compound, the empirical formula would be CH2O. That is the most reduced form of this compound. Okay, so that is finding the empirical formula. If these numbers right here were decimals, like the 0.5 or the 0.25, these are the numbers we would multiply by a whole number to get rid of that decimal. All right. For molecular formulas, molecular formula is just taking that empirical formula and multiplying it to get to the mass that you need, or multiplying it by the ratio that you need to get to the molecular formula. So molecular formula is different than empirical formula. Molecular formula is the actual ratio, okay? And it's going to be a whole number multiple of the empirical formula. So in order to determine molecular formula, we need to know the empirical and the molar mass of the compound in question. Okay. The molar mass of the entire compound is going to come here on top. Once we find the empirical formula, that's going to go on the bottom. So the mass of the empirical formula goes on the bottom. When we divide these two, it's going to give us a ratio. So let's say that the molar mass of the compound is 3 times bigger than the empirical formula. N would then be 3. So I would multiply, on the previous slide I had CH2O. I would multiply everything by 3, and I would get C3H6O3. Okay, so the molecular formula is just a whole number multiple of the empirical formula. But finding that whole number, we just take the molar mass of the compound divided by the molar mass of the empirical, and that gives us our whole number. Okay? That is our last slide. I don't need to keep these. Oh, I just hit keep. But I will see you guys in class. Come ask me questions if you have them.